In this video, we'll be going over a GCSE style question where we're going over vectors, and this is aimed for grade 9. This is a 6-mark question, 2 marks for the first part and 4 marks for the second part, and we'll be addressing both parts. CDEF is a quadrilateral. C to D is equal to A, D to E is equal to B, and F to C is equal to A minus B. Express F to E in terms of A and or B. Give your answer in its simplest form. So with all vectors questions, what we're going to do is we're first going to identify the path that we're going to follow. To go from F to E, we're going to follow the path of F to C. So F to E is equal to F to C plus C to D plus D to E. And now we're going to take the values in each route. So F to C is A minus B plus C to D, which is A, plus D to E, which is B. Simplifying this down, we are left with F to E is equal to 2A. For part B, M is the midpoint of DE. X is the point on FM such that Fx to Xm is in the ratio of n to 1. CXE is a straight line. Work out the value of n. What we're going to do here is we're going to find what n is by using f of m and then calculating roots to f of x. So what we're going to do is we're going to find two roots to f of x and use a technique called comparing coefficients to identify what the value of n is. The first thing we're going to do is we're going to find f to m. Now this follows a similar route of f to e, which is f to c plus c to d plus d to m. So writing it all out, we have a minus b plus a plus and d to m. So m we know is the midpoint of DE. So d to m will be half of what d to e is, which is half of b. So we add half b into our first equation, and so we have f to m is equal to 2a minus 1 over 2b. So for vectors, to make life easier for us, we're going to keep our main terms of a and b separate from their coefficients. So we could write 2a minus b over 2, but it's easier to deal with half b when considering vectors. We've now found fm. We're now going to find fx. And for f to x, we're going to use a constant k. And k is a fraction that when multiplied by f to m gives us f to x. So f to x is equal to k times f to m. So this is our fraction multiplied by our root. And so we have calculated f to m, and we're just going to multiply these values by k. So we have k times 2a minus 1 over 2b. And if we multiply our k in, we get 2ka minus k over 2b. So here, usually when expanding our brackets, we would put our letters in alphabetical order. But here we're trying to isolate k to our coefficient, so we can leave a and b as they are. Now we're going to find another root to f to x, and for this root we're going to go from f to c, then c to x. So not going directly from f to x, but we're going f to c, then c to x. So f to x we have is equal to f to c plus c to x. fc we have as a minus b, but we don't have anything yet for c to x. We are told in the question that CXE is the straight line. So with the same thing that we did for f to x, we're going to add another constant. We're going to call this y. And so y multiplied by c to e is going to give us c to x. So c to x is equal to y times c to e. And we know that c to e is a plus b. So we have y times a plus b. And when we expand it, we get c to x is equal to ya plus yb. Now we're going to place this straight into our equation from before. So we have a minus b plus ya plus yb. And what we can do here is we can join together the terms with b and join together the terms with a, and we can factorize in that sense. So we're left with ya plus a plus yb minus b. So in the first two terms, we're going to factorize a out. So we're left with y plus 1 in brackets times a plus, and then the second two terms we're going to factorize b out, so we get y minus 1 times b. And so now we have two different roots for f to x. So on the left hand side here we have f to x is equal to 2ka we're going to minus k over 2b, and we're going to label this as equation 1. And on the right here we have y plus 1 times a plus y minus 1 times b, the f of f to x, and this is equation 2. So what we're going to do is we're going to equate equation 1 and equation 2 because they're both e to x. So here we have 2ka minus k over 2b, which is equal to y plus 1a plus y minus 1b. And as I stated previously in the video, we're going to be using comparing coefficients. So since both sides of the equation are equal, the coefficient of a on both sides must be the same, and the coefficient of b on both sides must be the same. So what we're left with here is, on the left hand side we have the coefficient of a as 2k, and the coefficient on the right hand side for a is y plus 1. So 2k equals y plus 1. And for the coefficients of b, on the left hand side, minus k over 2 is our coefficient of b, and on the right hand side, y minus 1 is our coefficient of b. And so we have minus k over 2 is equal to y minus 1. And so what we're going to do now is we're going to rearrange both of the equations we have to isolate y. So for the equation on the left hand side, we have 2k plus 1 is equal to y. No, 2k minus 1 is equal to y. Sorry, 2k minus 1 is equal to y. And on the right hand side, we have y is equal to minus k over 2 plus 1. Now we're going to equate these two new equations to each other. So we have 2k minus 1 is equal to minus k over 2 plus 1. What we're going to do is we're going to move our values with k and our integer values to opposite sides. So by rearranging, we get 2k plus k over 2 is equal to 1 plus 1. And so we're left with here 5 over 2k is equal to 2. Now what we can do here is we can multiply both sides of our equation by 2 to remove the fraction. So we get 5k is equal to 4. K is equal to 4 over 5. Now this is only the fraction that we've multiplied f to m by. So now we have to find a way of finding the value of k. So we know that k is a fraction, i.e. the ratio of two values to each other. So f of x has the ratio of f2x has the ratio of n, and that to x of m is 1. Now if we take the ratio of f of x to f of m, we have f2x to f to m, the ratio of that. We have n in our ratio, n to n plus 1. And to turn this into a fraction to get our value of k, our value of k is equal to n over n plus 1. Now we here have a value for k that we've calculated. Our value of k here is 4 over 5. Now 4 over 5 should be in the form of n over n plus 1. By cross multiplying here, we can get 5n is equal to 4n plus 4. So n is equal to 4. So in vector questions where you have to find the ratio of lengths, or they give you the ratio of lengths and you have to find unknown values, the method that you should go for is trying to identify the different routes that you can take for that length. So here we have one route of going from f straight to x. We took the route of f to c and then c to x, but you could have also taken f to e and e to x.
As always, thank you for watching and make sure you subscribe so you don't miss out on any new content.